get dire today. Scientists send out devastating warning after tracking changes at Yellowstone's supervolcano. Scientists are tracking changes at the giant supervolcano that lies beneath Yellowstone National Park, but they say there's no need to worry right now. The western part of the Yellowstone caldera is fading, said Ninfa Bennington, a volcanologist with the U.S. Geological Survey and lead author of a paper in Wednesday's issue of the journal Nature. The caldera is a large volcanic crater left over from Yellowstone's last major eruption 640,000 years ago. It covers an area about 30 miles by 45 miles. The discovery means that the future of volcanic activity at Yellowstone is in the northeastern part of the park, and there's no chance of an eruption anytime soon. This volcanic system is not capable of producing such an eruption, Bennington said. For now, Yellowstone's mud pots will continue to boil, hot springs will continue to steam, geysers will continue to erupt, the earth will continue to shake, and fumaroles will continue to erupt. The vast underground magma pool beneath the historic park is still red hot, ranging between 1,247 degrees and 2,512 degrees, Bennington said. Yellowstone is one of the planet's largest volcanic systems, where plumes of molten core rise through layers of solid rock in the Earth's crust, heating and melting them to form a reservoir of magma 2.5 to 30 miles below the surface. In the past, this was often depicted as a single underground lava lake beneath the volcano, but newer mapping and imaging techniques have made it possible to see the complex reservoir system where the magma collects. Imaging techniques that have produced more accurate maps of the vast magma reservoir beneath the park show a large, deep pool of magma leading to a shallower pool closer to the surface to the northeast, which is connected to the park's famous hydrothermal system. To figure out how likely a volcano is to erupt, volcanologists calculate something called the melt fraction. The melt fraction is the ratio of the amount of magma, which they call fluids, to the total volume of the crust. Think of the Earth as a sponge, Bennington said, but it's not water that fills the holes and crevices, but molten rock. In volcanically active areas, there is a higher proportion of magma than Earth. The higher the proportion of magma, the more likely an eruption is to occur in that area. The mapping was done using magnetotellurics, which measures the electrical conductivity of what's beneath the Earth's surface. Molten rock, magma, is very good at conducting electricity, allowing for precise mapping of the areas where the magma is stored. The tests were conducted over several months by scientists from the USGS, Oregon State University, and the University of Wisconsin-Madison. What they showed was that while there are several large magma reservoirs beneath Yellowstone, they are separated from each other. It would be difficult to mobilize them into a single eruption because they are not connected, Bennington said. There is still a possibility that the northeastern part of the park could erupt in a catastrophic eruption similar to the one Yellowstone experienced 2.1 million years ago. In that event, volcanic ash reached from the Pacific Ocean to Canada and Mexico. They tend to reoccur about every 600,000 to 800,000 years, according to the U.S. Geological Survey. The most recent eruption occurred 640,000 years ago. It was known as a super-eruption because it released about 250 cubic miles of material, 1,000 times more than the 1980 eruption of Mount St. Helens in Washington state. Right now, the cavities in the sponge aren't full enough of magma to support an eruption. For that to happen, the system would need more magma to fill more cavities in the crustal sponge. Once the system reaches a significant portion of these cavities filled with magma, an eruption could occur. But we're not there yet, Bennington said. We're talking about geologic time scales. That's hundreds of thousands of years, and probably much longer.